This question relates to these approximations, what we call polynomial approximations for the value of tan. And this is actually how computers and calculators can find tan to whatever decimal that we need. And same with sine and same with cosine. And these are what we call polynomial series. And in fact, although they stop here at x7 here, x6 here, these actually continue. And there's a very clear pattern of how they continue. And these are called series. Okay, in fact, these are Maclaurin series that allow us to calculate tan. You learned this in the second half of calculus. So these series we can test. So here I've given the calculator values, and this polynomial is going to give us a fairly good approximation to that tan value. In fact, if we want a better approximation, we just go to the next position. Okay, and there's a pattern in which we can find that next expression. So typing this in, I'm going to go 0.5 plus 0.5 cubed divided by 3 plus 2 times 0.5 to the power 5 divided by 15 plus 17 times 0.5 to the power 7 divided by 315. And when I work that out, my polynomial series. So I'm going to just introduce some terminology for you here. My polynomial series gets this value of 5.5462 ... And so to the third decimal, this is already accurate enough for us. And that's really, we're only going to use the third decimal anyways in our calculations. We can do the same thing with sine. Sine, we're going to use this polynomial expansion here, and again, this one goes forever. This is actually what we call an infinite series, and this is only the first four terms of its infinite series, and we can actually get more. So if we use 0.5 minus 0.5 cubed divided by 6 plus 0.5 to the power 5 divided by 120 minus 0.5 to the power 7 divided by 5040, we get a decimal approximation of 0.4794. So again, to the third decimal and beyond, in fact, I think it's even beyond the third decimal, the accuracy of this series, using just the first four terms of this series, is accurate enough for us. And again, we can show that this series for cosine also works. So again, this is a different formula, but again, it's from the same process. We find these series with a certain process and a certain pattern, which you learned in calculus. So 0.5 to the power 2 over 2 plus 0.5 to the power 4 divided by 24 minus 0.5 to the power 6 divided by 720, and again I get 0.87758, okay, and this is, if we round this, you can see that the fourth decimal place actually is, I think it's accurate beyond the fourth decimal place. Okay, this one was a rounded value to the third decimal point, and that would give us the same value over here. So these are called polynomial series, and they have a specific name called Maclaurin series, and these can be found. There's a pattern which we will learn later on in calculus of how we generate this pattern to come up with these polynomial functions that approximate these trig functions here.